Welcome back to the second video on probability, which is permutation and combination. Yes, in permutation and combination we are going to build on where we stopped in the previous video. Okay, before we go on into that, firstly let us understand factorial notation. Now, factorial notation is just, factorial is an exclamation mark. If you have, this is a notation, something like this, yeah, they call it exclamation mark. Okay, if you have, for example, 3 factorial, what 3 factorial means is 3 times 2 times 1. For example, you have 10 factorial, it is what? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It ends in 1. So if you have n factorial, then what would be n factorial? It's you realize that it reduces, isn't it? This is minus 1, then n minus 2 times n minus 2. It goes on like that until it reaches 1. So that's what factorial notation. The knowledge of this is needed in permutation and combination. Okay, now remember we stopped where we're trying to get the number of ways with which one would be able to rearrange selections and rearrange selections and everything. Now that idea brings about permutation and combination. Okay, we wouldn't really go much into the technical aspect of permutation and combination. I will just explain what you need to know and the formula. Okay, now for combination deals with selection. Combination deals with selection because it doesn't allow double counting. It doesn't allow double counting, no repetition. So that's selection. And a very good example of it is you have girl A, girl B, girl C, girl D. Now you are picking a team of 2 girls out of girl A, B, C, D. You are picking a team of 2 girls. If I pick girl A and girl B, and I pick girl A and girl C, then I pick girl B and C, then I pick girl B and A, and I pick girl C and A. Now you'd realize that this team is same as this team, isn't it? This team also is same as this team. Why? Because it's still the same set of people that forms the team. Person A, person B, person B, person A. It's still the same set of people that forms the team. The only thing is just this one comes first, this one comes next. So in this case, these two are the same. They are regarded as 1. These two also, they are regarded as 1. That is, no double counting is allowed. This double counting is not allowed. They are regarded as 1. This double counting is no repetition is allowed. So in this kind of case, you use what? Combination. I hope that analogy is very explanatory. In this kind of case, you use combination. And a very good example is, just like I said, is when you deal with selecting. That's why I said earlier that combination really deals with selection. For example, how many ways can you select? How many ways, just based on the question we have, how many ways can you select 2 girls from 4? Now remember I said selection is combination. So you have 4 girls, you are trying to find ways with which you can pick out 2 from them. How many ways can you combine two girls in 4? Okay, now the formula for combination is, if you have n over r, n combination r, that's n factorial, n minus r factorial, r factorial. So from this, then you have 4 factorial, 4 minus 2 factorial, 2 factorial. Then you solve it. That's 4 factorial, 2 factorial, 2 factorial. That's 4 times 3 times 2 factorial. You have 2 factorial down there, that's why I stopped there. Okay, that's 4 times 3 all over 2 times 1. That's 3 times 4, 12 over 2, and that is what? 6. So you can select 6 ways. There are only 6 ways with which you can select 2 girls out of 4, and let's see if it is correct. Girl A, B, C, D. I can pick A, B, I can pick A, C, I can pick A, D, or I pick B, C, or I pick B, D, or I pick C, D. So these are only the possible ways with which you can select without repeating. Okay, that's combination. And permutation. In permutation is just the opposite, the typical opposite of combination. In permutation, double counting is allowed. In permutation, double counting is allowed. It majorly deals with arrangement. Double counting is allowed. So let's take, for example, now you have 1, 2, 3, 4. Now if I'm forming two digits from this, I can form 1, 2, I can form 2, 1. Now, is 12 not different from 21? Yes, 12 is very different from 21. 12 is very different from 21. 12 is different. So that's permutation. It allows the become fine. If you're dealing with this using combination, 1 and 2 is same as 2 and 1. But then for permutation, they are not the same. 12 is different from 21. 12 is different from 21. It's just like having 12 million in account and 21 million. There's a gap. There's a gap in between them. So that's just by the way. Okay, now what's the formula for permutation? Permutation is, if you have n permutation r, it is n factorial, n minus r factorial. There is no r. Combination has another r here, but permutation doesn't. So for example, how many ways can you select? How many ways can you form two digits out of 1, 2, 3, 4? How many ways can you form two digits can you form out of 1, 2, 3, 4? That's 4 permutation 2. 4 factorial, 4 minus 2 factorial, which is what? 4 factorial over 2 factorial, and that's 4 times 3 times 2 factorial over 2 factorial. That's 4 times 3, and it is what? 12. So that's permutation and that's combination. Permutation deals with arrangement, combination deals with selection. And a very good way to understand permutation and combination best is combination focuses more on qualitative data stuff that is not really quantitative. You are not really dealing with the quantitative value, but permutation deals with quantitative data. It's just like, take for example, when I said girls, remember we mentioned genders nominal. Yeah, it is in terms of the quality, not quantity. So qualitative combination is majorly qualitative data. Permutation is quantitative. Anything that deals with number, digits, that's permutation. Okay, now that brings us to another interesting thing on ways with which stuffs can be formed, or ways with which stuffs can be rearranged. Okay, okay. Now you see questions like, how many ways can you rearrange the word mathematics? How many ways can you rearrange the word mathematics? Now remember, rearrangement deals with what? Uses what? Permutation. Rearrangement uses permutation. And I want to find the number of ways with which you can rearrange mathematics. We want to rearrange the words, but then we can use permutation. Fine, we could have said 1 2 3 4 5 6 7 8 9 10 11 permutation 11. Remember, we are still rearranging the whole thing. It's not that we are rearranging it in maybe 4 places or so. We could have said 11 permutation 11, and it goes like 11 factorial 11 minus 11 factorial, and it is 11 factorial all over 0 factorial blah blah blah. 0 factorial is 1, so 11 factorial whatever it is the answer. Yeah, fine, we are correct, we're good. But in this case, there's some words that are kind of repeating them. There are some figure letters that are repeating themselves here. They're repeating themselves here. So if you have such kind, you do not do it directly this way. Remember, since we know that 11 permutation 11 is still 11 factorial, that is, if you are rearranging anything in its own number, it is still the number of its factorial. So you don't need to introduce permutation again. Then it becomes 11 factorial, but then you have some letters that are repeating, like M is repeating twice, so you have to indicate that 2 factorial. A2 appears twice, 2 factorial. T appears twice, 2 factorial. What else appears twice? We've done for M, we've done for A, we've done for T. I guess that is all. Yeah, that is all. So we've already indicated for this. Then we can now apply factorial. Sorry, I'm not with a calculator, scientific calculator here, so I might not put in the answers. I would employ you guys to punch this on your calculator and put the answer there. Okay, so this is how you do for stuffs like this. Now it brings us to, if you are told to rearrange, how many ways can you rearrange these digits? 2 3 2 4 5. How many ways can we rearrange these digits? Now remember, you could have used permutation. That's 1 2 3 4 5 permutation 5, but remember, 5 permutation 5 is still same as 5 factorial, so we don't need to waste our time. That's 5 factorial all over. This appears twice, so 2 factorial, and that's 5 times 4 times 3 times 2 factorial all over 2 factorial, and that is what 5 times 4, 20 times 3, 60 ways. You can rearrange everything you have here in 60 ways. Okay, I believe we understand that. I want to believe we understand that. Now that brings us back to the question we left the other time, picking balls and everything in a bag. In a bag you have 4 blue balls, 3 red balls, 2 yellow balls. If you are picking 3 balls at random with replacements, firstly find the probability that you are picking blue, red, yellow. Now remember, probability, firstly, what's probability of picking blue? That's 4 out of 9. Probability of picking red, that's 3 out of 9. It's still the same as 1 over 3. And probability of picking yellow is 2 out of 3. Yes, but then remember we didn't specify the order with which they were picked, so you have to tell all the possible orders. So the probability of picking, it can be blue first, then red, then yellow, or it can be blue first, yellow, and red, and it goes on like that. But then, instead of you wasting your time counting, finding the number of ways, let's find the number of ways with which you can rearrange blue, red, and yellow. How many ways can we rearrange this? That's what 3 permutation 3. How many ways can we rearrange this in its own self, which is still the same as 3 factorial? And that's what 3 times 2 times 1, which is what 6. I remember that is 6 that we got in the previous question. Okay, this one is a little bit straightforward. What if the question goes like this? How many ways can you what's the probability of picking 2 reds and 1 yellow? Now this is where something else comes in. Fine, you can decide to say red, yellow, and do it yourself manually. But then if the thing was more, if you're picking like 4, 5, 6, and you don't want to waste the time rearranging to know the number of ways, you just want to find one way, get the number of ways, since you know that they will all give, each of them will all give the same probability. So if you can know the number of ways, then you multiply it with one of them, you get the answer. So now the question is, how many ways can we rearrange red, yellow? Remember, you are rearranging 3 in 3 places. That's permutation, but then it's still the same as 3 factorial, so let's not stress ourselves on that. All over, it's still the same as 3 factorial, because a number permutation itself is the same as that number factorial. Okay, now remember, this is repeating. What would you do? Put this underneath 2 factorial, because this one is repeating itself, and that's 3 times 2 factorial over 2 factorial. That's multiply, then cancel, then get 3. So that means it's only in 3 ways with which you can do that kind of thing. Only 3 ways. So since you know that it is 3 ways, all you just need to do is get the probability of one of them occurring. Now this one is just for you to be able to quickly solve it. You are going to be doing computer exam. You don't have to wasting your time getting everything. This one is just a fast short route. Okay, so probability of picking red is 1 over 3 times 1 over 3 times that should be 2 over 9, and that's 2 over 81. Then since you know that if you do for the rest, it's still 2 over 81, and you've already known that the number of ways with which you can get them, with which you can rearrange red and yellow is 3. You just say 2 over 81 times 3, which is 6 all over 81. And if anything can go, it's okay. 3 here to 3 here should be 27. Okay, that is that. So that's what permutation and combination, and as well as rearrangement, that's what they are all about. In the next video, I'm going to try to solve one of your questions in your lecture notes. Thank you very much. I remain Olasende Faith. Bye.